It's recording now. So just for the sake of YouTube, hello everyone and welcome to the first HSA Google Earth Engine workshop. This is part of the agronomy graduate student stat workshop series. Thank you for taking time and being here today with us. So before we start, some housekeeping. So do not hesitate in making questions. Make questions that for sure will help our YouTube folks as well, you, to understand the platform. You can both unmute yourself or use the chat for that. And if you put in the chat, I can work with Logan and Luana and transmitting those questions to Ray. A recorded version of this webinar will be available on the AGSA YouTube page. And a special thank you to Dr. Ray Schwalbert for accepting our invitation for teaching this workshop. So Mr. Schwalbert is an agronomist and his research is focused on the use of data to guide informed decisions in agriculture. Most of his work is on exploring options to merge remote sensing data, crop modeling, and machine learning techniques for pushing the limits of predictability in agricultural systems. On his recent projects, he has been working on approaches for mapping change in cropland use, estimating cropland area, crop yield, and production, and using data from a variety of satellite sensors such as Landsat, Sentinel-1 and 2, MODIS, Rapid Eye, PlanetScope, and SkySat. Currently, Mr. Schwalbert is the manager of the Smart Co-op platform, an initiative of 30 cooperatives in southern Brazil. So Ray, I'll ask you to briefly mention what the Smart Co-op stands for, and the e-floor is all yours.
Thank you, Carlos, for the introduction. So hello, everyone. First, I want to say that I'm more than glad to be here talking to you guys today. So I'm gonna share my screen and have a brief presentation, just covering, who I am, a little bit about Smart Co-op. That is the project I'm currently working. Then a really brief introduction about Google Earth Engine, GE. So GE stands for Google Earth Engine. And then later we're gonna move directly to hands-on. So we're gonna try some code exercising because I think it's for sure the best way for learning a new language, a new approach for performing data analysis is just doing. And then I just left the code really open. So we're gonna build together, and then we're gonna see that it's gonna be really natural. So we're gonna face some errors during the process, trying to interpret the errors, because this is, I was reading, Carlos shared with me the questions that he asked during the application, and I was going through that information, and I realized that most of you guys are familiar with or are Python, some kind of program language, and so pretty sure you guys know that one thing that really helps a lot through this process is learn to interpret the errors. So usually, you can just copy, paste, putting on Google, and then we're gonna find some Stack Overflow, some page with really useful information where you can solve most of the problems that we're gonna have. So basically, I'm gonna try to live this as more natural possible. So we're gonna see that, sometimes we're gonna face some errors and try to understand and interpret them. So I'm gonna share my screen here. Let's see if it's here. So I have, as I mentioned, a really brief presentation. So let me present here. So just let me know if you are seeing my screen okay. So Google Earth Engine. So this is the topic that we're gonna focus today, GE. So we're gonna refer to Google Earth Engine most of part of the time as GE. So before starting, who I am. So Carlos introduced me. I'm Augusto Schwalbert. I'm PhD in agricultural engineering in Federal University of Santa Maria. So this is here in Brazil, and during my PhD, I spent most of part of my PhD. Actually, I was in United States in Kansas, so K-State, under the guidance of Dr. Ciampiti. So in my PhD, I was working basically with geospatial data analysis. So trying for training algorithms for predicting yield, for predicting planted area in cash crops. So in US, in Brazil, so this is pretty much what I did during my PhD, and Google Earth Engine was the main tool that I use, along with Python, with R, but for sure Google Earth Engine helped me a lot. And I was mentioned before that pretty sure it would be impossible performing the scale, the analysis that I did in my PhD if I don't have this amazing tool. And now currently I'm a digital agriculture manager in CCGL. So CCGL is a cooperative we usually call a second degree cooperative, which means that we have another cooperative is associated to us. So we act like a research institution, so representing those cooperatives. So we have several researchers here. We have a research area, research fields area here, and also now we have this new branch. There's the digital agriculture sector that I'm responsible for. So my team and I, we are responsible for training, for developing new technologies, for predicting things on agriculture. For example, the same things that I mentioned before. So we are responsible for this kind of initiatives here. And one of the projects that I'm involved in now is called Smart Cope. Carlos asked me to explain briefly a little bit. So Smart Cope is a project, and in some sense is similar to Google Earth Engine, because I mean what Google Earth Engine did was get a lot of data put in one place in an easy way for accessing and for working with this data. So it was prepared for researchers, for scientists. So in the same way, we are getting a bunch of data, a lot of satellite, geospatial data, and preparing, putting a platform for delivering to the farmers. So of course, we have much more limitations in terms of data analysis, but we are offering opportunity for the farmers for accessing information, for input information and for accessing information. So basically this is all about the project. So we are delivering to them satellite imagery, predictions like crop phenology predictions, yield forecast predictions. So this is what Smart Cope is about. So and basically it's a platform. We have a web version and an app version for the farmers use this tool. And our total public nowadays is around 170,000 farmers. So this is the number of people that potentially can use the platform. We didn't reach that amount yet, but I mean, we are working towards this potential. So basically, I'm gonna move to my next slide here. It's just 4, 5, 6 slides, so it's gonna be really fast. So what is Google Earth Engine? So since this platform is from Google, I guess I thought the best way for defining them is Googling. So just open Google and type Google Earth Engine to see what I got there. So basically, this is the definition that Google put for their tool. So basically, G combines I'm just highlight some words that bring most of the information related to Google Earth Engine here. So it combined petabyte data. So you can think that 1 petabyte is 1,000 terabytes. So that is a really large amount of information. So we have their satellite imagery and geospatial data with planetary scale. So all the plant, we have information covering all the plants. So this is another thing that is really important related to Google Earth Engine. So we can perform this kind of planetary analysis capabilities and make it available for anyone. So it's because it's free. So it's a free tool that is also really important related to Earth Engine. They just, there's some examples here, that some kind of analysis that we can perform, like detecting changes, mapping trends, and quantifying difference on the Earth surface. So this is what is Google Earth Engine is about. That is the Google definition. So I just bring some information here, why I think it's important to use and why it's used, why Google Earth Engine is useful. The first one is because you can perform analysis faster. When I say fast, it is really fast. It's much faster than you can perform in any local computer. So there is no comparison about that. Because it's free, the second one, of course, so there's no cost involved. I mean, anyone can access this amazing tool. It is really easy to use. So we have a graphical user interface, but also we have the coding section that is my opinion, is the most important because really unleash the power of Google Earth Engine. So you can use in JavaScript and Python. And recently, I think they released an API for using in R. I didn't check too much, but I'm pretty sure that they have that API as well. So today we're going to focus on JavaScript. So we're going to focus on this language because it's, in my opinion, I'm much more Python than JavaScript. But for Google Earth Engine, I really like to use JavaScript because it's much easier for setting everything up before using. So Python is a little bit harder for get everything running accordingly. So we're going to focus on JavaScript, but just keep in mind that we have also graphical user interface and Python API. So you can use, for example, in Jupyter Notebook. We don't need to worry about reprojecting data, but this is really important about Google Earth Engine and when we are mixing layers. So I'm gonna, in my analysis, I want to use Landsat, but I also want to use Sentinel-2 and modes. So each one of this satellite information has their original projection. And I mean, if you're running my computer, I need to reproject everything for making sure that all the pixels will match correctly. So in Google Earth Engine, you don't need to worry about this. Everything is gonna be on the fly. So you can run analysis in Google Earth Engine. Behind the scenes will perform all the reprojections, unless you want to control the projections. You can also control, but you don't need to worry about this. So this is really advantage of using performing this kind of analysis in Google Earth Engine. And the last one that I put here, you can run really, when I say really, I put in capital letters because it's really an advanced analysis. So we are gonna not focus on this today, this kind of more complicated analysis, but you can perform from machine learning to deep learning. So machine learning is this kind of algorithms that we have, like random forest, gradient boosting. So you have this branch of algorithms that you can run, but also we can run like really complicated neural networks. You can connect with TensorFlow. So it's really amazing what we can do with Google Earth Engine. So I just bring it here just for you guys to know that it's possible. If you have curiosity for exploring this, really support you. That is really useful. So what we Google, the Zoom was in front of my presentation. Sorry. So what will cover today. So basically, I'm just put some topics here and the script number. So I don't know if Carlos, if you have the chance for sharing with everyone the scripts, but I can just paste here in the message also. There's no problem. So basically, we're gonna. Oh, thank you.
Yeah, I shared that in the email, but I will paste that in the chat as well right now.
Oh, thank you. So basically, we're gonna cover like JavaScript 101. So really basic JavaScript, just for allowing you guys to use the platform. You don't need to know how to use JavaScript for, learning really deep knowledge about JavaScript for using the platform. I mean, the first time I used, I find out later on that it was JavaScript. I just get some scripts, start running, and then I learned later that this is JavaScript, so I'm using the platform in JavaScript. So you don't need to have deep background in JavaScript for using the platform. No worry about that. So we just cover some really simple aspects related to that. And then I just put some exercise that you can do that I think will be help and for you guys during your daily activities. So that, at least for me, this is the first tasks that I try to perform in Google Earth Engine when I start using. So the first one is how to download a single satellite image. So I just want to select one image and download it. So we're going to try to cover this. So this is the script number 2. How to download a bunch of images, like a batch download. So download like 10, a collection of images. So you also can do that. There is no any problem performing this kind of analysis. So this is script 3. How to reduce data to geometry. So what means reduce data to geometry? So basically, it is getting a polygon over an image and extracting some statistics. Like I want to know the average, like I have an NDVI image, I have a polygon, and I want to know the average for this field, for example. So this is what Google Earth Engine calls reduce. So we can reduce to mean, reduce to median, reduce to any kind of zonal statistics that you can imagine. So, and then we're going to start moving to a little bit more advanced options, how to build a function. So yeah, this is maybe will be a little bit more complicated in the first glance, but I think it's important because after you learn how to build, how to define a function within Google Earth Engine, then you really unlock a lot of possibilities for using the platform. That's why I just bring one script for focus a little bit on that, because I think it's really important. So at least, I mean, if you finish the workshop today and you don't know how to build a function, at least you have a script for as an example for running this later on. So the other one is how to apply a cloud mask. That is really something that is also really important. So this is the main limitation for sure of satellite imagery, is the cloud interference. So we have, like, for example, let's get Sentinel-2, for example, we have 5-day revisit time. Sometimes depends on the place on Earth, 2 days. So this is really good. But I mean, in the other side, we have Landsat 8, so 16 days. So if you lose one image, we have wait 16 days until you get a different one. So this is, I mean, when we think on an agronomist perspective, thinking on, for example, monitoring phenology, this is a lot of time. So when this cloud is a really big problem related to satellite imagery. But worse than that is if you don't have a good algorithm for removing it from the images. So this is how we're going to try to tackle also how to apply a cloud mask in the image in Google Earth Engine. And last one, how to map over a collection. So what means map over a collection is to get that function that we have. For example, we have one function that is for calculating NDVI. And now we have a collection of 100 images. And I want to calculate NDVI for those 100 images. So with one really argument, really simple, we can run really fast an analysis in a matter of seconds. We can perform, for example, NDVI for the whole United States. So this is, I mean, really good when you're running like large scale analysis. So this is what we're trying to cover today. And before finishing, so just bring here what we will not cover today, but just put a reference here if you guys want to go after this and check. So just later we can share the presentation. So basically, we won't focus on Google Colab. So this is a really nice tool, but I'm not sure that we could do one workshop specifically about Google Colab. So Google Colab is a Jupyter notebook that Google put online, and then everything is set. Google Earth Engine is already there, so you can use. I mean, it makes the life much easier for those who want to use Python and Google Earth Engine. So if you want to use Python, please check Google Colab. It will help you a lot. TensorFlow we want to cover today also, because I mean TensorFlow is the deep learning framework that Google have for running complicated machine deep learning algorithms like neural networks. So you can connect with Google Earth Engine. So this is also really good, but it's a little bit more complicated. We also will not cover how to run locally on Python if you want to use your own Jupyter notebook. And last R, just put a GitHub link here because the package is RGEE. So it's a kind of API that you can run Google Earth Engine via R. So I didn't test too much, so I'm not sure how is the usability, but I mean, I know that it's available. So if I know that most of you guys are familiar with R, so if you want to use, so here's as a reference. So this is basically the presentation that I prepared. Before moving towards, I just want to share this link with you guys, because this is a website that I put online maybe 1 year The goal is not about the website when I show you, but it's about what we can do using Google Earth Engine in developing developing tools, for example. So I'm going to stop sharing again here, another screen just to show you guys how you can use Google Earth Engine. So here. So this is the website. It's gonna load here, and then we have an app here. So in Google Earth Engine, you can build your app. So check it out here. If you click here, it's gonna load the app. So it was built entirely on Earth Engine. So we can see it's our Earth Engine environment here. And so here is a yield forecast algorithm that we have. Basically, you have, for example, if you want performing comparisons, for example, here we have 2003, here we have 2004, for example. This is corn in bushels per acre. So basically, if you push this bar and slide over the map, you're going to see how the yields change from one year to another in US. So we run analysis also on Google Earth Engine for performing the forecast. And basically, you can get, for example, here in Iowa, for example, here in center, you can see how the yield change from one year to another. So this is also we can do with Google Earth Engine. So this was just to show all the possibilities that we have here. So now I'm gonna stop the presentation and start. We can move to Google Earth Engine and start coding and trying to do some exercise to see how it goes. So I'm gonna ask you guys for accessing. So probably you're gonna, if all of you have like a Google account, you can just go and type Google Earth Engine in your browser. So I'm gonna type as well, Google Earth Engine. So if you press enter,
it would be good if you can share the link of your website in the chat so people can access that.
Sure, of course. So let's open here and then I'm going to share. So you can just go ahead and access this page. If it's the first time you're accessing the Google Earth Engine, you're gonna have a really small form for fill out. So it's just 4 questions. So we can wait like 1 minute or 2 for allowing you guys to go through this form and fulfill all the fields. So let me know if you have any problem. So I'm gonna start just accessing here. We can wait a little bit before starting coding. So while you guys starting setting everything up, I'm gonna just show what we have here in this first page. So this is not platform yet. So this is just the website. So we have here, Google Earth Engine, and we have a bunch of options here in this toolbar. So we have the data sets. So if you click here, you're gonna see all the data sets that are available on Google Earth Engine. So we have since satellite imagery, for example, Sentinel, Landsat, modes, so different kind of satellites like Sentinel-1, Sentinel-2, also available. Landsat 7, 8, Landsat 5, so we have several missions of Landsat available there. We have like
Ray, sorry to interrupt you, but I'm not sure if you're seeing the right screen. Not sure if you click it in data sets, but we are still seeing the.
No, I didn't click. Yeah, I didn't.
Okay,
click.
okay.
Now I guess you guys are seeing.
Yeah.
I see the right screen. Okay. Perfect.
Yeah, thank you, sir.
No, so we have the Landsat, all the Landsat information. We have like climate and weather information. So surface temperature, climate. We have atmospheric weather, so imagery, then we have Landsat, Sentinel, modes, some high resolution imageries on this National Agriculture Program here. It's available for US. We have land cover. So this is a really useful layer for performing analysis. So we have all the fields, all the crops in US for the last at least 10 years. So this is available here. Terrain information. And so we have different kind of data, and you can easily get it from Google Earth Engine. So let me go back here to, sorry. So we have, this is just the frequent asked questions, time lapse. So if you want to view your time lapse and enter this too much, enter on this too much, case studies. Then we have the platform that is, I mean, the place we're gonna focus today. So blog, and so the sign up. So I'm gonna enter on the platform and code editor. So this is the place you guys will perform all the analysis. So here's where the magic happens. So I'm gonna also paste this on the chat if you guys have gone to reaching this page. You can just click on the chat and probably will bring you to this page if you already have the account. Otherwise, you need to fulfill the form. So this is the Earth Engine page. So everything here is related to this environment for running JavaScript. So let's navigate a little bit and explore what we have here. So in the left corner here, we have a small section that we have 3 tabs here. The first one, scripts, where you have all your scripts. So if you click after setting your account, if you click in that link that Carlos shared previously, probably will upload those scripts here that you are seeing in my screen. So in the scripts that I prepared before for where we are gonna navigate a little bit. So you have your repository here. The second one is docs. So in docs, we have several functions that you can use in Earth Engine. For example, we have like, you can see here, you have like algorithms already built in. You have classifiers, cluster analysis, functions for running like building confusion matrices, some functions for building like objects in Google Earth Engine that we're gonna see in a few minutes, filters, geometry. So we have a lot of functions that you can use for different kind of analysis. So when the last one is assets, where you have your data. So we don't have anything now here, but you can upload your data from image to shape files, KML, so any kind of vectorial or raster data you can just upload and it will be available here. So I will, for example, I have like my fields, I map my fields that I'm using, for example, in my research, and I want to perform the analysis in that region. For example, I can just upload here, just clicking new here and upload is gonna bring Google the data field is gonna be available here for pushing and incorporating your script. So it's really easy for doing this. And just clicking probably new and you can upload here. GeoTIFF, like shapefile, CSV. So those are the formats that Google accept for uploading the data. So this is what you have here. In the middle, we have the console where you're gonna type your code and run. So this is prepared to receive JavaScript coding. So here is where you're gonna write your code. In the right section, we have also 3 tabs. The middle one is the console one is where you're gonna see the objects we're gonna print. So for example, we have like an image. I want to see the specifications about this image. You're gonna print it and you're gonna be showing in this region here. So I'm gonna show in a few minutes. You have tasks. So here is everything that we import or export in Google Earth Engine and how much long it takes. For example, in red, you can imagine it was a fail. So it ran for 52 seconds and fail. If you click in the question mark, it's gonna say why it fails. So it's here as a message. And as I mentioned before, it's really important learn how to read this message and extract the information about this message, because this is will help a lot. So don't be afraid for if you, I mean, don't get afraid if you get like a error message. This is pretty normal. You just need to learn how to read it and extract information for change your code and then try and run it again. So it's completely normal. And then we have some tasks that I performed that was a success. For example, I download one image, here an image drive example. So this is a Landsat image and field is a vector file, so probably is a shape file that I download. So when I download something from Google Earth Engine, it goes to your Google Drive. So you don't download directly to your local computer. You download to Google Drive. So it's like you're removing for Google Earth Engine environment and moving to Google Drive environment, that object. It can be a raster, like an image, or it can be a shape file that in the GE lingo, shape file is going to be feature collection. So feature collection is a synonym for shape file for this kind of vectorial data. And image, it's for it's an image, as the name suggests. An image collection is a collection of images. So we have feature collections that are a collection of features. For example, I have a shape file that has 10 fields, for example. So this is a feature collection. Every field is a feature. So every geometry is a feature, and then we have a feature collection. And for image, we have image and image collections. So this is the four main types of objects that we're going to use in Earth. Maybe lists also are important. I'm going to show in a few minutes. And here in the bottom section, we have the map. So we can change for map to satellite view. But basically all the information that we're going to plot using Google Earth Engine will be displayed in this region here. So for example, I want to plot a Landsat tile. So that information will be displayed on this region here. So with all the reprojections already performed correctly. So Google, as I mentioned before, Google is responsible for making this everything under the hood. So all the reprojections will happen under the hood. So basically this is everything that you have here. If you click here in this question mark here, I think you can get general shortcuts. So this is really helpful also. So if you click here, we're going to have some shortcuts you're going to use during your code exercise. So this one here is really important: comment and uncomment selection of the current line. So this is here how to add a comment. So this is a shortcut for adding a comment. We're going to use this during our exercise. So it's Control key and slash. So depends on the keyboard. Sometimes in my case, it's not a slash, it's a different key, but if you try slash and it didn't work, probably it will be a key really close to slash in your keyboard. Depends on how it's set. So this is pretty much about this environment. So now you guys are familiar with this. We can go back to the scripts and start our exercise. Please feel free to ask if you have any question. So I'm gonna.
Ray, I have a question. But this is basically a complete geospatial platform, right? So is there anything that we can do on ArcGIS, for example, or QGIS that we can't do in the Google Earth Engine?
Yes, there's some kind of analysis you can't perform or not yet. And I'll try to explain why. So this is a really good question, Carlos. So why depending on the analysis will be harder for running on Google Earth Engine. So this Google Earth Engine was built based on this is what I'm saying, based on two principles. The first one is parallel processing. So everything that you're gonna run in here, it's gonna run on parallel. So you have several computers spread in different locations and you run your code. So each portion of your code will run in parallel. So depending on analysis, it's really hard for running in a parallel fashion. So, and that's why sometimes depends on the kind of analysis not available. For example, machine learning, the depending on the family, the kind of machine learning analysis is not available, not yet here on Google Earth Engine. So there's a kind of, specific analysis that sometimes you're going to find in ArcGIS, QGIS that you won't find here. So that I believe that the main reason because why you're not finding here is because it's really hard for running parallel. So this is the first principle. The second one is that all the configurations, all the sets for running this analysis is already done. For example, let's suppose you're going to run your script on BioCat in Kansas, for example, on the high performance computer in Kansas. The first thing that you need to do is prepare the infrastructure. So you need to say, how much memory you want, how many CPUs or GPU you want. So you need to prepare this before running. This is really, sometimes it's really hard for those that don't have a strong background in computer science, for example. And the second part that you need to worry about is preparing your coding for running parallel. So we need to prepare the infrastructure, and then you need to prepare your code. And then you can run analysis, in a server, for example, HPC in parallel. So in Google Earth Engine, you don't need to worry about the code, neither the infrastructure. So everything is already done. You don't need to worry about the analysis. So this is the main advantage, probably the limitation why we don't have some analysis available here on Earth Engine. So you guys will note that sometimes some analysis will take longer than others. It's because, there's a kind of line and you submit your request, and then sometimes I'm pretty sure that if I run this analysis again, will take like 20 seconds or 45 seconds, because it depends on how much, we'll wait until starting processing, because there is a bunch of requests, a lot of people in the world doing requests, and then Google will just arranging this for running everything in parallel. So, but anyway, keep in mind that sometimes you'll find some analysis that won't be able to run in a Google Earth Engine. So I'm going to open the first script here. So we have the JavaScript 101. So I'll just put some comments here. The first thing that I want to highlight is how to put a comment. So as I mentioned before, you can, there's two ways for adding comments in Google Earth Engine, JavaScript as well. So you can use the double slash. So if you put before, at the beginning of the line, double slash, it's going to be considered as a comment. So will not be considered in your code you are running. In the second one is put this slash star and star slash in the end. So we're in the beginning, in the end of the sentence. So this is also your sentence becomes a comment. So it won't be considered in the code. So if you press Control key and slash, it becomes again a code and a comment. So this is the shortcut that I mentioned before. So basically, there is no way. Really frequent question is if you can run row by row in Google Earth Engine. In JavaScript, you can't. You're gonna run all the script. So if you want to run just one row of your script, you need to select everything else and make it a comment. So you can use Control slash, so it becomes a comment, and then you can run your analysis just for one specific row. So if you're running Python, like in Jupyter Notebook or in Colab, you can run just one cell, then you can run row by row, but here you can, it's all or nothing. So basically this is the first one. The second one, keep in mind you need to declare the variables. So every time you're going to create a new variable, you need to use this primitive that's called var. So var a, for example, it's going to create this variable here, the variable 5. So if I run here, for example, let's see. So everything else is a comment. So this is the only portion of the code that is valid. I'm going to run here. So you can press run, or you can press here. run. It's Control key enter. So if you press Control enter, it's gonna run the code, but nothing happened. Why nothing happened? Because I didn't ask for plotting, and I didn't ask for printing. So actually run, but I mean we don't have any information for displaying for the user. So if I want to see here, I need to use print. So print A, sorry, print A is going to print 5 here. That is a number. So it's being displayed here in this section, in this part of the this view. So basically, this is the print command we're going to use a lot. So this is actually the number 3, how you can print the variables in the console. So number 4, let's explore some types of data. So here is the part that is more important. So you have this, I mentioned before, you guys have image and image collections and features and feature collections. So those 4 are far away the most important types of data that you have on your Dwarf engine. But also we have the dictionaries that are somehow important also, and the lists that are, I would say that is the number 5 in a ranking of importance. So those are the main type of data, and how I build or how I pull this data to Google Earth Engine. So basically what Google did was get data from different places and put everything in their server. So if you want Landsat imagery, you're gonna go here in the search bar and type Landsat, for example. So Landsat. So here we're gonna see that we have rasters. So when you have several kind of Landsat data, like collections, for example, we have Landsat 7 raw scenes that there is no atmospherical correction. We have Landsat 8 all AI. We have Landsat 8 raw scenes also. Again, this is 7, this is 8. So we have Landsat 1. So we have several options and more because I mean, just as a preview. And also we have some tables here with this kind of data. So let's suppose I want to pull Landsat 8, but I want surface reflectance correct, like the surface reflectance image. So probably if we put surface here, it's going to restrict a little bit more my search. And then I have Landsat 8 surface reflectance tier 1. This is the highest quality data that I have on Landsat 8. So let's click on it. So then it's going to open this window here where I will have more detailed information. So we have a brief description. So here, what is this collection? This collection is about atmospherically corrected surface reflectance from Landsat 8. So we have the bands. So here we have the name of the band. So this is important, the name and the position, because we can search filter bands based on their position or based on their name. So this is V1, position 0. This is the index is 0, is more like Python. In R, usually the first row is 1. In JavaScript, is going to be the first one is going to be 0, the index, and then the second one is going to be 1. Just keep it in mind. So we have some properties here also, and then here we have a collection is needed. So what is this? So this is the code we need to call for getting this data. So I'm gonna just copy here. I'm gonna close. And then let's start with image collection. So this is the first one we're gonna explore. So I want image collection. So what is the first thing that I need to do? It's put a name. So it's gonna be image. Let's go just collection. So collection. So I put var, I put a name, and now I'm gonna call the code for pulling this data. That is EE image collection. EE dot image collection. So this is the function, and this is the argument. So Landsat LC08. So this is the code for having Landsat surface reflectance, Landsat A surface reflectance tier 1. So but we are not applying any filter. So basically we are pulling data from all the planet since the beginning of the mission. So this is a lot of data. Probably it's gonna take too long for processing, for displaying this information. So we can start filtering that information. We bring us to the topic number 5. We're gonna cover all this, but I just move quickly to number 5 here, filtering. So there's different kind of filters that we can apply, but I can filter based on data. So for those are familiar with FAR and already use pipes, this is the idea here is pretty similar. So basically we're gonna call this, so this is gonna pull all the images, and now we're gonna call filter. So basically it's dot filter. So we're gonna call dot and the name of the function. And then also we can call in the next row if I want, but we need to pass the dot together. So the dot will go together with filter. So let's put filter, for example, date. So I have a function that is filter date that can be applied to an object of this kind here that is not image collection. So filter date, and I'm gonna filter, no worry about the way they need to pass the arguments. So this is something that you can easily learn later on. So I'm gonna ask for an image, for example, from 2020, December, let's get July, for example, 1st. And so this is from this date to 2020, July 3rd, for example. So now we are restricting on space, on time. So we are only looking for image within this period. Now I'm gonna restrict a little bit more on space. So I'm gonna filter again, bounds. So now I'm gonna look for a specific region on the map. So I can use filter bounds, but it can be a boundary, but it also can be just a point. So I want to create, I will create a geometry that you can create by using this options, these tools here. I'm gonna use this one here. So I'm gonna Manhattan and just put a pin over Manhattan. So now we have, so it create the code here on top. So var geometry, so the name is geometry, is a point on this coordinate. So if you expand a little bit, you can see more information about this. So now I have a point and the name is geometry. So I'm gonna filter bounds to geometry. Now, finally, I will print it. That's it. Print. So if you guys pay attention, we'll see a little I here. So missing semicolon. So the code will run anyway, but it's good if you every time you finish your function, you finish with a semicolon. Here and here. It's just Google is just remembering you for putting the semicolon. I mean, if your code is short, there is any problem about that. I mean, if your code start becoming really long, like hundreds, maybe thousands of lines, then sometimes we start facing some errors because we are not putting the semicolon. So if you remember, just every time you realize that there's a little y here, just put the semicolon for avoiding any problem. So this code here is going to print this collection. So I'm going to run here. Now we have here number 5. We print before. Remember, you run all the code. So we're running this, and we're running this. So we have number 5, and then we have an image collection that was printed here. So JSON, what is JSON? So JSON, don't worry too much about this. This is a kind of data structure. So this is a non-relational database. For those who are familiar with SQL, for example, SQL, SQL is a relational database. So this is a non-relational data kind of data that is stored in a JSON format. So this is the way that Google choose for storing this data. So we have image collection here, and we have 2 elements. So based on this research we did, we just find two images. What makes sense since we have one image every 16 days. So we have two images. If you expand a little bit, so if you click here, you're going to see a bunch of information related to this image. And then we're going to, in features, you're going to have the image. So we have two images. Here's the name of the image. So one is from, I can expand a little bit more for finding information here. This is July 8, and this is July 24, 2020. So the dates of the image. And here we have more information related to the geographical position of these images. So, and then we can dive a little bit deeper on this structure, and then we're going to find details related to the image. For example, we have the bands here, all the bands. So we have from B1, B2, B3, and so on until those last bands here from image 1 and image 2. So remember, this is an image collection. Why is an image collection? Because we have two images within image 1, and image 2. So if I just want one specific image, there's two ways for getting that. You can use, you can perform the same analysis using, for example, for image 1, and then we're going to use ee.image instead of image collection. But here, instead of passing this address that is related to the collection, you're going to need to pass one a little bit harder because you need to know this name here. So this is what you need to pass here in order to get this specific image. So I'm going to put this here. Now I'm going to print image 1. Hope this works. Yes. So we have here an image collection, and here we have an image. So this kind of two types of objects that we have within the Google Earth Engine. So also we can extract one specific image from the image collection. So we can just, for example, let's suppose I just want this same image is the first one. So we can call just image 1 B. Let's call it this, and I'm gonna call the collection. So the collection by its name because we just put a name to it, and then I'm gonna call the first. The first one is the first one that we have in this order here. So here, the first one will be this one here, index 0. So basically, there's another way for printing here that is really useful. Instead of typing again here print and then open parentheses and image 1 underscore B, you can just put aside here, aside print, and then it's gonna print it. It's pretty much the same. So you see it's the same image. We just search from this collection here. So, but if I want the second one, how I can do that? We can call second. No, fortunately, there is no function called second. You need to perform a transformation before getting the second one, on the third one, the fourth one. You need to get this collection and turn into a list. So is the third object that we have. So we saw image collection, image, and now we're gonna see a list. So basically we're gonna get, so let's for a list. So I'm gonna create a list 1. So I'm gonna get the collection, and then I'm gonna put 2 lists. So this is a function that is gonna use for turning image collection into a list. And then the argument that we're gonna put here is the number of elements in the list. So if you don't know the number of elements you have in your collection, just put a really big number here. Let's put 1,000, for example. There's no problem with that. So I'm gonna aside and print again. So I'm gonna print list 1 here. So now I have list 1. It's not an image collection anymore. Now it's a list, and I have 2 objects within it. First image and the second one. So it seems really silly to do that, but actually after transforming the collection into a list, you can use the get argument. So you can just raise here and you can say get, and you can get the index 0, or you can get the index 1, or you can get -1 is going to be the last one also. So let's get 1, for example. That's going to be this image here. So I'm going to put aside here and print. So here we have the second image. So let's put this. You see, it's a different one. It's 24 and here's 0.8. So probably, I mean, here there's one really important thing happening. I mean, if I run again, I want you guys to pay attention that this name here won't be image while running. For example, I'm going to run again. So you see, computed object. So when you run and see computed object in somewhere, it means that Google Earth Engine doesn't know anymore if that object is an image, or if it's a list, or if it's a feature collection. So, I mean, despite of, I mean, it's writing image here, I mean, actually Google Earth Engine doesn't know anymore. So you need to tell him again that this is an image. Because if you try to use this object in an analysis later on, I mean, you're going to get an error. So it's just, I mean,
Right. I noticed.
Yep.
I noticed you use get 1 to get the second image. So the list starts in 0.
Yes, the list starts in 0. So exactly, if you put 0 here, so the index will be the first one. It's pretty much exactly how it appears here. So 0 for this one, 1 for this one. So in this case, I'm going to run again. So you're going to see computed object. So what I need to do in this case is, I'm going to separate a little bit here, is just to tell to Earth Engine that this is an image. So this, I'm just telling to Google, this is an image. So I'm going to run again. So now image. So in this case, everything's go okay, and we won't face any problem. So then, so this is lists, image, and image collection. Now we have two more types, the feature and the feature collection. So if you import a shapefile using a for example, and print, it's going to be a feature collection. So let's try to search for a feature collection. I think we have one about states here. US states, let's see, tables, yeah, US states 2019. So I want to click on it. I'm going to see a description, table schema, some more information here. And I'm going to here again, I have the code for pulling this information. So I'm going to copy this. Let's close this one. It's here. Close. So I'm going to put here var states equal. And I'm going to paste this. So EE feature collection and the address. So I'm going to just go ahead and print it. I'm going to print here separate. Let's print states. Run. So it's running. Let's see. Usually, I mean, you're going to realize, you guys will realize that performing analysis using vectorial data is going to be, it's going to take much longer than raster data. So here we have like the JSON. So I'm going to click it on it. So again, we have some information. Type is a feature collection, an ID, and version. The columns that we have here, just this is the column that we have in the shapefile, for example, in DBF in shapefile. And then we have the features. There are these states in this case. So each feature, it's a polygon or a multi-polygon in some cases. That is one state. So if I click here, this one here, I want to click on properties, and then we have the same columns that we saw before, and this name Vermont, for example. So this is one state. So this is shortcut, yeah, VT. So you have all the states here. So I'm going to close here. So you guys see feature collection, for example. Now let's try to filter this feature collection to get a feature. just one state, for example. So how we can do that? We can first turn into a list and apply a get. So this is work as well. But also in this case, for feature collections, you can also use these filters here. So let's try to filter. Let's see if you can apply filter. So I'm gonna, this is a little bit different structure here. We're gonna call filter. And then, so in this case, we call filter data. So this is a red prepare script. But the most primitive way that we can call a filter is just calling filter. And then here, you're gonna specify what kind of filter you want. In this case, I want this kind of filter here, filter. I'm calling EE filter because I'm gonna build an object of type filter, because I have one object of type filter collection, image. Now in this case, it's a little bit different, but don't worry about that. So just worry about the way that you need to code for getting this information for now. Not equal EQ. And then I'm gonna put here that I want, for example, feature collection. Let's get one randomly here, property. I'm gonna try to use this one here. So I'm gonna put this like this. So this is the name of the column and will be equal to, in this case, I want 2 cancels. So yes, let's see if it's gonna work. And now I'm gonna assign. So when, just for speeding up, I'm gonna just put a comment. So everything else is going to become a comment here. So we're going to focus only on this one states. So let's run. So we have 2. We have 2 because we print, but I put aside print and print states again. So that's why we print 2 twice. So we still have a feature collection, but now we have just a feature collection just with one element. So I have here. So this is going to be property. Oh, Kansas. So we have Kansas here. Kansas, all the information related to this state. So if I still want to extract the feature, you can try like this now. To list. One. So why is it important to learn how to extracting this data? Because I mean, later on, when you start coding for real in your analysis, you need to turn from one kind of data in another. So it's really good to learn how to extract this information and how to moving and selecting all the data. That's why I'm focusing a little bit on this. So to list 1 because I know that it's just one element there. I'm gonna try to get, I don't know, I'm not pretty sure if that's gonna work. So let's try print. Computed object, yeah, now it's a feature. But if you realize, since I turn it into a list and just get and print, Google Earth Engine lost the reference and it doesn't know if it's a feature anymore. So it's computed object. Now I need to just wrap everything here and say that's EE feature in this case, just for remembering here him that we need to, I mean, we are working with features. So this is going to probably solve. Yeah, now feature, it's going to be okay. So now we saw all the, I mean, the most important kind of data that we have, like image collection, image feature collection, and lists. So with those, you can perform pretty much any kind of analysis. So we also saw filter. So those structures here, you can use filter data, filter bounds for imagery. You can use filter and build here, like EE filter equal. You can use also LT for less than or greater than, like GT, as you use equal. So there's different options. So if you come here in docs and put filter here, you're gonna find a lot of options that we have. So like equal here, expression greater than or equals GP, GTE greater than and equal. In list, if you want to pass a list and check if within that list intersect for geographical information, containing less than, we have a bunch of options that you can, it's impossible to go through everything, but I mean, also for dates, you have like calendar range, you have filter date, the one that we used before, date range contains, and then you can put a left field and right field, day of the year, if you want. I mean, there's several options just for exploring the dots a little bit. So now we cover filter. So let's move to functions. So functions is here. Before I'm gonna make adaptation here. Before moving to functions, I'm gonna move to show you guys how to plot that information here. That also is, it's important. So I'm gonna get this states here and plot here the boundary of the state. So for plotting information here, regardless if it's an image or if it's a feature collection or feature, so you cannot plot image collection, but you can plot feature collections. So there isn't any problem with feature collections, but image collections you can't. So they are a little bit different on that. You can plot a feature, you can plot a feature collection, but you cannot plot an image collection. So probably if you pass an image collection here, we're gonna get a new. So if you want to plot image collection, you need to combine all the image and all the bands, and then you can plot. So let's plot. So for plotting, you're gonna use this function here. It's called map.addLayer. So map.addLayer, and then you're gonna call the object you want to plot in this kind of states. So let's see states, and then to enter, and then here we have cancers now the boundary. Let's try to do an exercise here. Just I'm gonna remove this key feature here in this parenthesis here. So now I'm gonna try to plot the same thing, but without telling Earth Engine that is a feature. So let's see what happens. So you see, cannot add an object of type computed object to the map. So was a feature collection because it was within, was a feature because it was within a feature collection. But when you extract out using the list and get, Google will lose the reference, and then you need to tell again, this is a feature. So every time you see when you print, the things start running here, you see that computed object. Just remember that you're probably going to face an error in some moments in your code. Just keep it in mind. Just running again, and then you're going to plot here. So sometimes it's, I mean, you just get stuck in a silly error like this, and you just need to put e feature here. So now you know how to map. I'm gonna later we can explore a little bit more about map.addLayer, so we can I can show how to add, for example, for an image, add the legend, how to put the color scale for example NDVI. So this is what I'm gonna explore in a few minutes. So the last three are, I mean, they are kind of together. So the first one is functions. So this is a little bit harder than the other things that we saw here, but it's not that hard. So again, we need to declare a function, for example, function f. Let's call, let's call a function really simple, that is divided by 2. I want to something divided by 2, so it's going to be d2. So I'm going to call, this is going to be a function of x. So this is, I mean, the logic is the same for Python, for R. I'm going to open the curly brackets. And here, the first thing that I need to do is tell again Google Earth Engine what x is. So I mean, you cannot write a function that maybe you can, but it will be really, it's much harder writing a function that is going to work for feature collection and for images also. Because the first thing usually, that we're going to do in a function is tell, oh, what is x? So x, I'm going to call again var a. I'm going to create an object within the function, and a is an image that is x. So I'm telling Google, oh, this x here is actually an image. Now you are dealing with image. And then I'm gonna create var b that's gonna be e and then image r. In this case, a actually. It's gonna be a divided by 2, by n, for example, or by 2, because the name of the function. And then later I'm gonna return b. So this is my function. Returns the output. It's gonna be also an image because a is an image. But in this case, I don't need to tell because Google will keep this reference for this example. But if you want, just for make sure, you can say just for. There's no problem doing this. So of course, so we build an image. It's gonna, the input will be a function. The input is gonna be an image. The output is gonna be an image, the original image divided by 2. So this is what the function does. So we basically, it's clear here that it's gonna be applied in the bands of the image. Now we can try to apply this function to all the images on this collection here. So I'm gonna uncomment this. So now we have the collection again. So we have the function here. And then map, what map does. So map basically get all, so just run again just for printing the collection. Let's print here, print collection. And if you want to, just for the sake of organization, you can just put a name here. It's going to be easier for you for following your objects here. You can say like collection and then print the collection. And then we're going to be here a name here, and now we have an image collection here. So, and then we have several bands here, and I want to apply this function to those 2 images. So if you guys allow me, I'm going to change a little bit this function. I'm going to write an easy one. I'm going to call S2 instead of B2, and this function actually is going to select, and then I'm going to put here a list that is restart as a bracket. 0, 1, 2, 0, 1, 2, and 3. I'm just make this change here. So what I'm doing here, so just for introduce you guys this new function select. So when you apply select to an image, you're basically selecting the bands. You can select based on their name or their position. So I'm gonna be selecting bands 1, that is index 0, 1, 0, 1, 2, and 3. So when I when I map this function over this collection, I'm gonna get this function, got this function applied to each one of this image. So I'm gonna have a new collection with 2 images, but instead of having 12 bands, I'm gonna have only 4 bands. So if it works, let's see. So I'm gonna create a new variable that's gonna be collection2, s2. Oh, sorry, it's collection, and then I'm gonna map. So map is the part responsible for getting this function and applying to all the objects within the collection. It's the same that we have in Python and R. Same logic. And then I'm going to call the function s2, and then I'm going to print. Let's see if will get an error. So running, now we have a new collection here, 2 elements like this one here. So let's open the image. So if you see here, band 1, 2, 3, and 4. So we apply this function here to select this image. Now you guys can use the imagination and think all the kind of functions that we can apply to image. So for example, I can get just an example, for example, for we think we can build a polygon that is encompassing all the United States. Then I can pass this polygon as, for example, this filter bounds here. Filter bounds. I'm gonna pass this giant polygon, and then I'm gonna pass 10 years of or 5 years of in the range of this filter data. So I'm gonna get all the Landsat images in US in the last 5 years, and then I'm gonna build a function that is NDVI. So basically, instead of selecting, my function will select the near infrared band, and then it's gonna subtract the red, then divide it by near infrared plus red. And then I'm gonna apply this function to this giant collection, and then I'm just in a matter of probably, I'll not say that it will take seconds, but probably will take like 1 minute, no more than that, for running this. And then we're gonna get maybe a little bit more, but still, I mean, it will be super fast comparing if you're trying to do it locally. You're gonna have like the 5 year time series of NDVI for the entire United States. So, and then we can do this just using this commands that you just learned here in a few lines of code. I mean, if you have time, you can try this at the end of the workshop. So this is the map. So we use the functions, we use the map, and now the last one is the reduce. So what is reduce when we use Google Earth Engine? So reduce, it's apply some zonal statistics, for example. If I have put it, for example, here, I have this polygon here, and that's the state of Kansas, and I want to plot, for example, 3 tiles of Landsat 8, and I want to average those and get the NDVI average on over Kansas, for example. And then I'm gonna use the reduce methods. For example, as we have the filter, we can type here reduce, and then we're gonna see that we have several types of reducers. Let's put reducer here and search a little bit here. So well, let's put EE reducer dot. So let's see what we have here. Let's search a little bit. So we have reduce regions, reduce resolution, reduce. I want to find those ones here. I have reduce count. We can count the number of pixels that we have within Kansas using this reducer. Reduce, let's see what we have here. Those we use for building histograms, kurtosis, or max. So you can get the max value of NDVI in Kansas. You can have the mean, you can have the median, the minimum. So there's a bunch of options. Also, you can use, or the variance, you can calculate the variance of NDVI within Kansas. So you're gonna use calculators using those reducers. I'm not using now because I'm gonna move for scripted 2, but we're gonna get back on this really soon. So this is the first script that we have, just for introducing you to JavaScript and some of the functions that we can use in Google Earth Engine. So I'm gonna just save here. Complete one. So let's go back, scripts. Let's move to the second one. So now I know how to pull an image a filter based on data, filter based on location, an image or a collection, and then if I have a collection, extract one image. Okay, but if I want to download that image, how we can do that? So this is going to be really fast. So I'm going to open here. We have already prepared script here. So here we have two geometries that I draw on the map here. So I'm going to plot those two here. It's hard to see because the zoom is really far away, but it's here. Those are the two geometries that I have. So the red one is the geometry, and the green one is geometry 2. So you can note that, I mean, I can draw here, for example, and every time that I draw anything here, it's going to generate an object here, and there is a corresponding code for this object that you can retrieve. I think if you, let's see, if you click here. So here you can retrieve, for example, geometry 1, so var geometry, and then you have this EE geometry polygon, and this is the way that Google build the geometry polygon. So this is the code behind this action here. So here we have geometry 3, for example, that I just draw there. So basically, this is just the code behind the action, just to show. So basically, what we're doing here. So we have 3 geometries. We have first we're gonna search in a collection. So basically, again, var s2, because now we're gonna deal with Sentinel-2 image collection, and then we have this is Copernicus / s2 on the right surface reflectance. So we're gonna get surface reflectance Sentinel-2 data. Filter data again. I'm gonna filter based on this range here of data. Filter bounds on based on this geometry here. We can print here. So let's move the zoom to the side here. Print here. Then what I'm doing here is selecting the first image. We already saw this also. So basically, I'm gonna get S2_1. It's our S2. That is our collection here first, because I'm getting the first image, and aside print because I want to print here. Then I'm mapping. So map add layer. So because I want to map over this region, this background map here. Then let's go a little bit here again. So this is, I mean, doing pretty much the same thing that we did. How about selecting the 4th image? So you can do, remember to list 100, print again, and then I just put everything within the map add layer. Instead of writing section by section, I just call EE image. So I'm again telling this. Remember why I'm telling this, because this when I turn into a list and apply a get, the Google will lose the reference. So I need to remember that is an image. And then mapping. So this, we don't need this section here. I'm gonna just remove from the code. Let's see if we'll have effect. No. So I'm gonna, yeah, we can remove this. So we have the mapping layer, and then we're gonna here. So what is, I mean, this is pretty much the same. The only section that is new for us is this one here. So we have done all this for getting an image, and now we want to export that image. Remember, when you export an image from Google Earth Engine, we will not export to your local computer. You will export for your Google Drive. So the Google Drive that is linked to the same account that you have. So we have a Google account. Now you have a Google Earth Engine section, and also you have a Google Drive. So basically, I'm going to run this just to see how there's inconsistency here. I'm going to just refresh it, but again, that part of the code here. So I'm running. So let's focus on this last section here that is new for us. So what we have here. So we have a function that is called export image to drive. So naturally, you can use this only for export images. So So if you want to export a feature collection, there is another function that you can use. So if you don't know which one, you can come here in docs and type export. And you're going to see that we have export image that is in red. So it's not working or will not work soon. So that's why it's red. All in black, will okay, you can use. So we can export an image to an asset. So if you export this image, it will appear here to an asset. So if you export to cloud storage, so this is going to be another kind of way to storing data. So if you're gonna focus later on, for example, connecting Google Earth to TensorFlow, then TensorFlow cannot get the data from Google Drive in a easy way. So it's going to be much easier if you export to cloud storage, but you need to pay then, so it's not completely free. And the one that I use the most is export to Drive. So basically, you're going to export to your Google Drive. So we have export image to Drive. And then if you click here, you're going to see that we have several arguments that we can pass. The image you want to export, a description, a folder in Google Drive, file name prefix is optional, dimensions is optional, region, if you want to export, for example, if you have a tile, but you want to export just a tiny region, you can specify here, scale. So this is one thing that you need to pay attention when you export an image. For example, I want to export a Sentinel image. If I didn't pass scale equals column 10, saying that scale is 10 meters, Google will understand that by definition is going to be 1,000 meters. So Google will reproject Sentinel-2 to 1,000 meters and then will export. So if you want to use the correct scale, you need to come here and specify this. So this is pretty much optional. There are options that we have here, not going too much in detail. So basically what I'm saying here, I'm saying this image here, I want to export. So instead of selecting out of the code, I'm selecting within. There's any problem. I can call this XX. And here, for example, var XX, and then just for having my code a little bit organized. So now I'm exporting XX. So I'm gonna getting this image collection here. Oh, sorry, this image here. Selecting so the image here. I created here. I'm just passing here, selecting bands 2 and 7, and then export. So image description. This we can call test, for example. Folder, we call test again. Test. Scale 10 meters, because I know that this image has 10 meter resolution. Oh, if you doesn't know the resolution, I think you can retrieve that information use something like this. Let's try range XX, and then you can try projection. And then you can type, scale. So when I print this whole object here is going to be equal to that resolution of the bands 10. So 10 meters. So if I have bands with different resolutions, probably I will get an error here saying that I can run this if my bands have different resolutions. Then you need to select a specific band and look for the resolution of that band. So we can try just removing the selection here and running just to see what happens. Yeah. The bands of the specified image contains different projections. So use image select to pick a single band. You don't need to pick a single band, but you need to pick a band with the same resolution. And then it's going to work. So just I'm going to let it here just for having this information. So now let's try to run this. So export description scale in region. I'm gonna export region 2. So I'm gonna focus on this green region here. So I'm gonna run. So, and then you can see now it's orange, this task. So if you click task here, we have task called test here because we put description test. So I press run, and then we have one more chance for specifying everything that we pass within this function. You can change the name, you can change the scale, you can change the location where you're gonna send this image, the drive, the file name, or you can just press run and then start running. And probably it's gonna take like 23 seconds, something like that, because this is exactly the same example that I'm running here. So let's see how long it's gonna take until we get this on Google Drive. So if I go to Google Drive, we're gonna see that this is probably there. So let's wait a little bit until finish running. I can save here and then refresh the page. Oh, 20 seconds. So there we go. We have the image. Now we can come here and Google Drive. I'm going to refresh again. So we have test is this one here, and here's the image. So we have the pivots here. It's just that small grain section that we select. So if you have a field, for example, we can just pass that field there, and then it's gonna export just the boundary of your field. So we have here, and then I just need to download from Google Drive. Just click here and download, and then you're gonna get the image native file. So that is the way that we can export an image, a single image. Now I'm gonna get back here. So, and how about exporting more than one image? I want to export all the images within my collection. So we can do that. I just prepare another one, just batch download. So here's pretty much the same. So we're gonna call in a collection, filtering by date, filtering by bounds. This is just to, this is not too important. The code is just to size. So this function here, we're gonna apply to collection just to count the number of elements that we have. And I'm gonna print here just to see how many images we have within this collection here. So what is different in this code? The first row. So what do we have here? So we have batch. What is this? So let's run to see. Sorry. Oh, it freezes because it's a little bit. So let's see. So probably batch will not print here. So I don't know if it's a kind of object you can print, but basically here batch, I'm calling repository that someone prepared. It's pretty much similar that in R when we download a library and call a library. Then we're calling this user feature prints and GE tools batch. So basically now we're gonna have access to some functions that we hadn't before. So let's see. Oh, here, let's download. So we just call this because someone wrote the code. Of course, we can write this function here. The name of the function is this, but it's really complicated. So it's much easier if you just call this and get from someone else that already did the hard job. So I'm calling this. Remember, this is the same then in R, just calling a library. Then I'm searching for a collection. So I'm counting the number of elements that we have within this collection. And then I'm going to apply this new function here, this batch download image collection to Drive. And then I'm going to pass collection, the name, the scale is the same one, but Landsat is 30 meters. So this is Landsat. And then the region, geometry 2. So let's run this. So it's pretty much the same. You just search the collection and then pass this function. So it's going to freeze a little bit because it's a little bit more heavy. Now if I'm coming here, I'm going to see that we have 3 images waiting for downloading. So basically this is because we have 3 elements within our collection. So this is basically the equivalent to type three times the function export image to drive, and then pass the first image, export image to drive, pass second image, and so on. So you can basically apply this function and have the image here ready for downloading. So this is just a really quick way for downloading more data easily. So let's move to our last 2 scripts quickly. So number 4. So I want to say, I'm going to change yes. So number 4 here, reduce over geometry. So we're gonna probably take more, 10 more minutes we can finish. So reduce over collection basically is that function that I mentioned before, reduce. So again, we are having an image collection, we are filtering. Here in this case, we are already, I'm doing something that is a little bit different, that is applying this normalized difference here. So this is a more faster way for calculating any DVI and any kind of index that had the same formula than DVI, just changing the bands. So band 1 minus band 2 divided by band 1 plus band 2. So here's the first band, here's the second band. But if you want to calculate a more sophisticated vegetation index, I want to calculate, for example, GCVI. That is a different formula. Then you need to write the function as we did before, and then map over the collection as we did before. So, but in case of DVI, you can just go ahead and call this function here, and then this is already applying the function and mapping over the collection. This is a shortcut for applying and for calculating DVI. So this is basically what we are doing here. So what is different on this request? So we have again filter data. We have again filter bounds. We have just one assigned print here. So it means that it's going to print everything before this assigned print. So it's going to print this structure here. So then we have again a filter. So and we are filtering for something that is greater than, and then I'm calling cloud cover here. So this is a metadata that we have in the image. So basically we are filtering for tiles of Landsat that have cloud cover greater than 70%. So here it should be lower than, or less than 70. So we can put 90 here just to see what happened. And then we are getting the first image. And then actually we're not applying to the collection. Sorry, we're applying to the image because we're getting the first image. I had missed this here. So I'm getting the first image and then applying this function here and calculating NDVI. So we're gonna have Landsat is gonna be actually Landsat NDVI image. And then I'm mapping. So let's try to run this section here first to see what happens. Let's remove this bar here. So let's zoom out to see here. So here I'm mapping this Landsat tile. So I'll change the color here. We can zoom in and we can see. So this is the image we just mapped. So what we're seeing here is, if you click here, you can see that you are seeing NDVI. This is ND is ND is because that formula also always map a band with this name ND. And we can apply better scale. Let's stretch a little bit. So it's gonna be from 0.2 to 0.83. And let's build let's put some colors here. So apply here, and I'm gonna put, for example, red, yellow, green, finally blue, and then apply. So here we have NDVI image. So we can see how fast we can calculate an NDVI, for example, and run again. So it's going to matter of second, you can calculate NDVI. So it just lost the legend because I wrote here. And basically what we can do later is, let's see here, is the reduce. So I'm gonna apply a reduce. So basically, again, we have some geometries here. So we have geometry 1, geometry 2, and what I will do here is reduce to mean over this geometry. In this case, I just put 60. I should put 30 actually because it's the right resolution. I just put 6 because I want to speed up the processing. So I'm gonna considering a band resolution of 60 meters. So this, it's gonna, let's see what is field geometry 2, just for us having an idea. So let's open here. So if you search a little bit, probably you're gonna see somewhere in geometry 2. But it's really hard to see. So let's close the image. Maybe it's gonna be easier. Well, we can build a new one. That's gonna be faster. So let's do the following. I'm gonna open the image again. I'm gonna zoom in for a specific region, for example, this region here, and I'm gonna build a new layer that's gonna be geometry 3. So geometry 3 is gonna be this one here. Now I want to calculate the NUVI of this image over this region here. So I just come here and change to geometry 3. Now I'm gonna run again. So, and then here, you guys will see a feature collection. So the feature collection is this object here that I got from this image here after applying this reduced region over this geometry here. So reduced region is a function that you use for reduce over a region. And then the arguments that we have to pass is the, when you say collection, is actually feature collection that could be just one polygon. In our case, it's just one polygon, geometry 3. And you pass a reducer. In our case, it's min. It could be max also. And then it's going to calculate the max NDVI. To run again. So now we have the max. So if you access feature here, property, you're going to see that the max value is 0.84 within this region, while the min is let's say 0.48. So, and then you're going to print, and finally you're going to export. Since this one is a shape file, we're going to use this function here, export table to drive instead of image. So basically we're going to pass the collection, that is basically feature collection field, the description, the folder, and the file format. And here we have shape, but we also have different options. So we can just copy this and paste here. And we're going to see that we have export table. Click here, we're going to see that we can export them. CSV, JSON, GeoJSON, KML, KNZ, shapefile, or this one that is specific to TensorFlow. So this one is if you want to connect to TensorFlow. So this is all the kind of tabular data that you can export from. And again, it's going to be exported to your Google Drive. So if you can, your desk, we're going to see here field. If you run, press run. Again, here you can choose again and run. So then you're going to export this geometry to our field, to our Google Drive. So this is the fourth script that we have. The last one is really simple one. I don't spend too much time on that. I'm going to save here. So this one, it's basically the same thing that we did, map over a collection. The only difference here that I want to emphasize is this really complicated function here. So actually this one is just a function that I wrote for calculating the A and DVI. So it's basically the same thing that we did before, but here select the band 5, subtract, divide. So I just wrote. So this is not complicated about this. Here we have a collection, but the most important part is here. So here we have a huge function that is really complicated. Was not me that wrote this function. Actually, I got this from my script that is here in examples. So here in examples, we have several scripts. If you come here to cloud masking, you're gonna have several scripts for cloud masking where you have several functions that someone wrote to you. So if you come here to Landsat, for example, you can get here this one here, Landsat surface reflectance. So this one you can apply to collections with surface reflectance Landsat 8, as the name suggests. So I got this function from here, and I just paste here. So basically you're going to see it's a really, really complicated function, but you don't need to worry about this. Let's just close this. And the function is called mask L8SR. So mask Landsat 8 surface reflectance. So, and then in order to apply a mask and remove all the pixels where we have clouds in this collection, basically what we need to do is map this function here over this collection. So really simple. So I'm gonna map here, and then I just, I'm gonna map and plot here, map add layer, just plot here the comparisons before and after applying the mask. So I'm going to run here. So this is just So this is just options for mapping. So basically here, let's zoom out a little bit, and then we can see in a better way the comparison. So let's close everything. So here we have the first image. The first two tiles. So here we have one tile where we have some cloud. So I'm just getting one image within that collection for plotting. We apply the function for the entire collection, but just selecting one to show you guys how it works. So here we have the original image with the clouds, and here we have the result after removing the clouds. So I'm gonna just close this image and just leave the water. So you can see that really complicated function detect where the cloud is located and remove from the image, apply a mask. So it becomes a new value within our raster file. So, and this is the function that for clouding masks. So basically, just refreshing here, we define the function. So this is a different way for defining the function. We could also do something like this that we did before, that is called var, and the function name equals. So this is equivalent to this. I mean, it's the same thing if you pass like this or build in a different way. So there's no problem. So we build the function, we search the collection, apply some filters, and map this function here, and then we instead of selecting, so this is a little bit different here. Instead of selecting one specific image, we apply this median here. So it means basically we got all the images within that collection and compress and just got the median of all the pixels. So basically turn this collection in one image. So we could select, but in this case, we just mosaic and compress everything, combine all the collection in one image, and then we just plot just to see how the filter works. So basically, this is, I mean, with this we cover all the 5 scripts that we have here. So we still have some 10 minutes. I'm gonna close here. So if you have any question yet, please, I mean, be more than glad in answering. So I'm gonna just stop sharing here my screen.
All right. Thank you very much for sharing all of this with us. If anyone has a question, do feel free to turn on your microphone and your video if you would like. Otherwise, you can also enter questions into the chat and we can direct them that way. Something to keep in mind is that, like all of our workshops are, this one was recorded and will be made available on YouTube, so that if you didn't capture quite everything as the presentation was going on, you can always go back to YouTube and fast forward to the section where you stumbled and work your way back through. Well, seeing no questions, I really appreciate you. We really appreciate you coming and talking to us today and working through this on something very new for us. This is the first time that we have utilized this system in a workshop.
Oh, excellent. Excellent.
thank
Thanks
you,
for
Ray.
thank you for the invitation. I was really glad on having the opportunity for talking about GE and whatever, sharing any knowledge. So, I mean, feel free to reach me out anytime if you have questions.
Thank you, and thank you everyone for coming today.